Hi Math 95. In this video we're going to work through some examples in section 11.1 where we're working with quadratic equations and some applications of radicals. So the first thing that we are going to remind ourselves about is what a quadratic equation looks like. They're written usually in this standard form like this ax squared plus bx plus c equals 0. We don't want a to be 0 so that we actually get this x squared term here in the front. Otherwise, if that a is 0, we're just going to get something that's linear, this bx plus c equals 0 kind of thing. So we want to make sure a is not 0 here. Some quadratic equations, as we've seen before, can be solved by factoring and using the zero product property, right? We would factor this trinomial on the left side and then say each one of those factors individually could have been equal to 0. Somebody had to be 0, and solving it that way. But sometimes it's not possible for us to factor this trinomial on the left side, so we have to come up with some other techniques. And one of the techniques in this video we're going to be talking about is what's called completing the square. So let's first remind ourselves of a technique we need when we're going to do completing the square. We need to make use of the square root property when we get to completing the square. So remember, the square root property really is just an operation that allows us to use the relationship between squaring and square rooting. So if we know an expression squared is equal to some kind of a number, then we know that that expression, that u, whatever it is, u can be something crazy and written in terms of an expression of x, then we know that that is equal to the square root of d or negative square root of d. And usually we write it something like this, right? And so usually this property is technically saying that when we take the square root of both sides, we get two roots, right? We get u equals plus or minus the square root of d, and don't forget the plus or minus. Remember, the plus or minus is produced whenever you are creating a square root, right? So if just regular square root of 4 is given, it's not asking for plus or minus, it's just asking for the principal or positive square root like this one. Okay, so let's consider an example of this square root property here. So let's solve the following equation. Let's do 4x squared plus 9 equals 0. So first of all, notice that this is in fact a quadratic equation. It only has two terms, but it has this x squared thing in it, which makes it a quadratic. This binomial here on the left side is not factorable, right? It's not a difference of squares. There's no greatest common factor, so we're kind of stuck. So we should try to attack this thing with the square root property. What we need to do is isolate the thing on the left side that has been squared. That would be, or could be, the x squared. So let's try to get the x squared by itself. So the first thing we should do is to subtract 9 from both sides and get 4x squared equals negative 9. Then perhaps divide by 4. We get x squared equals negative 9/4. And now notice we have something squared equals a number, right? Making use of the square root property here, we get x equals plus or minus square root negative 9/4. Okay, and that can actually be simplified a little bit because we know that 9 is a perfect square and so is 4. We have the square root of a negative number here, and before we talked about 10.7, that would have been a really scary bad thing, but now that we've worked through 10.7 and we know about complex or imaginary numbers, we're able to write this in terms of I, right? So if we rewrite this just for a second as the square root of 9/4 times the square root of negative 1, right? Break it apart using that property of radicals here. Then what we're able to do is write that x is equal to what? Plus or minus the square root of 9/4 is the square root of, nope, not the square root, just the regular number, 3/2, plus or minus 3/2, and the square root of negative 1 is I. Okay, so our answer here to this quadratic equation, our roots are plus or minus 3/2 I. Good. Let's consider one more example. Again, if you needed to go back and watch that one more time, remember you can pause it or rewind. Okay, let's try solving this one. How about we do x minus 3 squared minus 10 equals 0. So remember, we're trying to get the thing that's squared all by itself. So it's not yet that there is an expression squared all by itself on the left side. We first have to add 10 to both sides. So we've got now x minus 3 squared equals 10. Now notice we have something squared equals a number. And when we have something squared equals a number, we can write it as that something equals plus or minus square root of the right side. That's making use of the square root property. Okay, well, we don't have x isolated just yet because we have to add 3 to both sides. But I want you to be careful here and remember that this plus 3 does not get to work inside of the radical, right? The only way you can make changes to inside of this radical here is if you multiply it by another kind of square root and then make use of the property of roots where the product is one giant square root. So this plus 3 does not move inside of the radical, it just lives out front, right? So since we have plus or minus the square root of 10, we really have 3 plus the square root of 10, or 3 minus the square root of 10, right? Remember, this means there's two answers, right? This really means we have 3 plus the square root of 10, or we have 3 minus the square root of 10, right? It's two things, okay? So be careful to realize that those are the two values of x that satisfy that equation. All right, I think at this point we are ready to think about now completing the square. And remember, we talked about this in class together, where we worked out how to complete the square, how to take a binomial of this form here and turn it into a perfect square binomial like this here. We have to add a certain third term here, and then it'll turn into a square of a binomial. So how we get what we have to add here is to look at this middle coefficient right here, the b in the middle living right in front of the x. What we do is we take that b, divide it by 2, and square it. And once we have that, that's the thing we add here. It'll turn that two-term thing into a three-term trinomial, right? A trinomial here, which has a nice factorable form. Okay, so let's consider an example. So let's try using this property to solve a certain quadratic equation, because really that's where this is useful. Let's try solving this quadratic equation. Notice first of all it's not factorable, and we can't use the square root property on it because we can't just isolate all by itself the thing that was squared and have all the x's on one side. If we tried to isolate x squared here, we would have some x's living on the other side, and we don't want that to happen. The square root property says you isolate it as some kind of squared stuff equals a number, and we can't get that in this situation. So let's try completing the square. The first thing we want to notice is that we just want to work with x squared plus a number times x. We don't have to want to work with this -1 that's living right here. Yes, so let's move it out of the way. Let's move it to the other side of the equation. So now we have x squared plus 4x equals 1. Okay, notice here that we have the two terms that we're starting with here. If x squared plus bx is a binomial, then we can add something, right? Okay, so let's maybe make ourselves a little bit of room here, because if we're going to add something living right next to that 4x, we want to give ourselves room to add it. So we're going to put something right here, and what we're going to put there is the b over 2 squared. Okay, so what is b in this case? B is the number living in front of x, that's 4, right? So that means that b over 2 is what? 2, which means b over 2 squared is 4, right? It's just squaring this thing right before it. So that means here I'm going to be adding 4. So let's add 4. Okay, but remember what I just did is added 4 to the left side of this overall equation. Yes, I added 4 to the left side of the equation. But remember, if you're going to add something to an equation, you have to add it to both sides of the equation, which means if I added 4 to the left side, I have to add 4 to the right side also. Okay, now what happens is, notice we haven't changed what the equation says. We added 4 to both sides, the equation is still true. But now this left side, it factors, right? The left side factors perfectly, remember, because we wrote it we can write it as a square of a binomial like this, right? And what does it factor into? It factors into x plus, what does it say? X plus b over 2. That's just this number right here. Yes, x plus b over 2, which is 2, squared, equals, and what does this right side equal? 5. Notice now that we have something squared equals a number. This is where we apply the square root property, right? Okay, to say that if x plus 2 squared equals 5, then x plus 2 must equal what? Plus or minus square root of 5. And so if we subtract 2 from both sides, we get x equals, remember the subtracting 2 doesn't work with the square root of 5. It's totally separate, right? So it's just -2 plus the square root of 5, or -2 minus the square root of 5, right? And those are our two solutions to the quadratic equation we initially started out with using completing the square. Let's try one more example. Because things get a little bit trickier if, for example, you have a number living out in front of the x squared. Okay, let's solve this one for x. Again, take a second and try factoring it. You'll notice that it doesn't factor here. It also does not allow the square root property to be immediately applied, so we can't use either of those techniques here. So let's try completing the square. Again, let's make our first step to be isolating the x's on one side and getting all the numbers on the other side, so that we have just the x squared plus bx to work with. So that means we have 2x squared plus 3x equals 4. Well, notice over here in completing the square it says if x squared plus bx is a binomial. What's in front of that x squared right there? There's an invisible 1 living right there, yes? That's a requirement for using this completing the square technique. If we have any other kind of a number living in front of that x squared right now, that's not good. We don't like that, right? So what we have to do is get rid of this 2 that lives in front of the x squared. Well, how can we turn a 2 into a 1? Right? Now I know you might be thinking subtraction, right? You might be thinking, well, just subtract 1 or something. But remember, if we write minus 1 right here, we can't subtract the 1 from the 2 because it's 2x squared, right? So we can't just subtract a 1. So how else can we make this 2 that lives in front of the x squared in multiplication a 1? Well, we could divide everything by 2, right? If we divide both sides by 2 like this, we would get what? X squared plus, oh boy, this doesn't divide nicely, but that's okay. We can just write it as 3/2 x equals 4 over 2 is 2, right? Again, if you need to, take a second and understand why I divided 2 into both of these terms right here, right? Remember, it says 2 divides into each of those two terms, right? So this becomes an x squared from that one, and this becomes a 3x over 2. 3x over 2 is just 3/2 x, okay? Remember, 3x over 2 is 3/2 x. Okay, those mean the same thing. Okay, we talked about that in class one time. Okay, so now we have x squared with a 1 in front plus bx equals a number. Okay, so in this case, b is equal to 3/2. Well, to complete the square, remember that means we need to take b over 2. What is 1/2 of 3/2, right? b over 2 is 3/2 over 2, right? But by flipping and multiplying, that would mean this is 3/4, right? Or 1/2 of 3/2, which is 3/4. So b over 2 squared then is this thing squared, which is 9/16. So that's what I'm going to add here to my two terms on the left. So I have x squared plus 3/2 x plus 9/16. But remember, when I add to the left side, I must add to the right side. Okay, the left side factors into x plus, remember it factors into x plus b over 2 squared, right? Oh, right here. X plus b over 2 squared. So x plus what was b over 2? b over 2 was 3/4 squared equals, oh boy, what is 2 plus 9/16? Well, let's see, 2 is what, 32/16? And if I add 9/16 to that, what do I get? 41/16. Okay, 41/16. Now we can apply the square root property. Because I have something squared equals a number, so I get x plus 3/4 equals plus or minus square root 41/16. Oops, 16, there we go. And finally, just subtract 3/4 from both sides and you're there. X equals negative 3/4 plus or minus square root 41/16. And actually, notice that there's a 16 in the denominator living right here, and the square root would want to act on that. So instead of writing that as square root 41/16, I'm going to apply the square root to the denominator. The square root of 41 isn't going to simplify, so I still have that square root of 41 in the top. But in the bottom, when the square root applies to the 16, I'm left with a 4 in the bottom. Okay. All right, so we're going to end this video because it's getting a little bit long, and in the next video we will do some examples of using the distance formula and the midpoint formula.